So here we go. We've got sums and differences for today. I refuse to read to you. You all can ascertain how or anything you don't recall regarding rules for addition. To simply summarize, okay, I'm going to give you some quick things. A negative added to a negative will always still result in a negative number, right? Negative 6 combined with a negative 2, of course, will still be a negative 8. In contrast, when you're dealing with the negatives and positives combined, you simply find the difference between the two and choose sign based on the one with the larger absolute value. Okay? That's for both of these when you're combining negatives and positives. So for the first one, say a negative 6 combined with a 2. I'm not going to do a plus plus 2. You guys know what I'm doing here. I'm going to subtract, which is the difference between those two items is 4. And I'm going to choose to make it a negative because the sign of the one with the larger absolute value is a negative. Okay? In the same way, were I to do a positive number, say 6, and even that, as much as it looks like third grade, I am actually adding a negative. Okay, that's the technique you guys have been introduced to over the years. So I find the difference between the two and keep the sign of the larger absolute value. The one with the larger absolute value happens to be that positive 6, so it stays a positive. Note, I rarely write a positive, right? That's just understood. I rarely will write that, and you'll rarely see that in a textbook. It's just cumbersome, okay? So all of that sums and differences business can be seen in your example 1. If you want to go ahead and flip over to example 1, I'm not going to read to you, but I do have an example 1 that you can also work with. All right? Here's page 22, and this is my version of example 1. It looks like this. It says simplify, so that means find the answer that you can to the best possible, simplest possible version. It's going to look like this. Okay, this is mine, it's not theirs. What I find easiest to do is to commute the items so that they are all grouped together by sign, which would look like this. I'm going to put my negatives together first. Again, I know this seems completely simple, but it has to be reviewed. Okay, I have now lumped my negatives together, which leaves me with my positives, those. Okay, I'm going to lump my positives together as well. Plus 18 plus 2. What I do next is I add together each sign. So 12, 15, 16 in the negative. And I add together the other sign, 20 in the positive. Going back to the techniques listed above, you're going to tell me the difference is 4. Assign the sign of the one with a larger absolute value, which would be the 20. Therefore, your answer is a positive 4. Okay, did I lose anybody in that neighborhood? Awesome. Notice that they gave you in your book 2 solutions. You could simply add from left to right, or, and I like to use the solution 2 model because to me it's just quicker for me to flip-flop them around, group them, and add them together. Okay, so your book gives you either the order of operations, which is left to right, but I utilize the commutative property to move, and then I do associate everything together and group them, but by commuting them, by nature, you're going to end up going left to right. Okay? Well, left to right here anyway. Example 2. We're moving on to subtraction issues. Okay? And they just stated for you, or I just stated for you that in this one above here, I wrote it as 6 minus 1, and I reminded you that when we subtract, we simply add the opposite, and you guys have seen that since you were in elementary school, at least I think 7th grade maybe. So in algebra, and in algebra 2, they give you a definition of subtraction, and that's basically telling you that to subtract merely add the opposite of the number being subtracted. Okay, again, I'm writing it very shorthand style, but add the opposite, which they've given you algebraic terminology. So like x minus y is equivalent to taking x and adding the opposite of y, whatever that is. For example, 6 minus 2 is equivalent to 6 plus negative 2. Okay, that being said, if you mentally do that, you go back to the rules I gave you for sums. Okay, you start with whatever they give you, convert it to an addition problem, and then use the rules that you've already been given. It can be tricky though, so we're going to practice that just a little bit. The example 2s that I'm going to give you are going to be just a little bit different, so make sure you do my example 2s and not the ones that the book gives you. Okay? All right, I'm going to flip. Can I flip? Example 2. Okay, these are mine. Example 2. It says simplify, and my first one is going to look like this. Here we go. Again, easy peasy. For those of you snoozing, we're laying the groundwork for some more difficult things to come. Remember, add the opposite, and specifically of negative 12 here, or of 12. It's positive. Subtracting means add the opposite. So it looks like this, 17 plus a negative 12. Okay, that's all that means. When you eliminate the operation, the 12 is positive. So we're adding the opposite. It still ends up with a negative 29 nonetheless, right? For those of you that don't need to think that way, that's fine. I don't care how you do it. I've always done it this way, so it's never been something I've had to learn. It was just how my brain worked. Okay? Whereas, if I said to you, and here's my example B, negative 17 minus a negative 12, okay? Again, we're going to add the opposite. So it becomes a positive positive, and everybody's already answering it, and that's awesome. It became a positive positive because we added the opposite of negative 12. And that gave us negative 17 plus 12, which is a negative 5. Again, are you all still on the trail with me, or is anybody lost in the woods? Okay. And look at C and D really quick, seriously. Look at C and D in your book. Is there anything on C and D that needs more reviewing? This class is pretty good. I don't have to worry too much. Okay, then I'm going to move on to my example 3. For sake of your time. Example 3 has a longer problem, and it's all numeric, and it gives you just a handful of numbers where you're adding and subtracting. To me, that's really similar to example 1, but I'm going to just go ahead and do it. So it goes like this. This is my example. Okay, 11 minus 9 minus 16 plus 7. Okay, this is my example. So just like the previous one, we can group everything, but first make sure you change it to add the opposite, okay? And adding the opposite would look like that. Okay, that's what that would become. Then I'm going to group everything. Looks like I have two negative numbers, the -9 and the -16. So I'm going to group those, first commuting them. And of course, I'm going to work them anyway, from left to right. And then I've got my 11 and my 7. Okay, so this is a -25. And I'm going to associate those to give me that positive 18. And it looks like you're going to end up with a difference of 6. But because the larger of the two is a negative, it should be a 7. 5, 6, 7, Mrs. Myers.
I'm writing what you're writing, so...
It's all right. No worries. So it's a difference of 7, and it's a negative. Okay? Absolute value, if you throw absolute value in, which is what you're going to see at the top of page 23, when you're dealing with absolute value, use all the rules you know for absolute value. Start by solving for your absolute value, and then go from there. Okay? Again, simplify. Okay? Simplify what? Well, here's my example. Looks like this. Yep, these big lines, I try to make them look like absolute value. Step 1 is to find anything within a symbol, a grouping symbol. So 5 minus 12, would you agree with me that if I add 12 to -12 to 5, I have a -7? If I can count on my fingers and toes? At absolute value of -7 is what I'm going to look for there. The other piece is 13 plus a -2, right? 13 plus a -2, so I should have a positive 11 in there, right? 11. Absolute value is 7 and 11, and that's what's being subtracted. Carter, you could teach this lesson. Yes, you could. Add the opposite using the principles or the definition of subtraction, which states instead of subtracting elementary school style, you just add the opposite. Saves you all kinds of time. You should have come up with a -4, assuming I can add. All right. Examples 5 and 6 start to introduce variables into this thought process, and it doesn't change what you do. Okay, so do not think that, uh-oh, there's a variable, I gotta totally do something different. You really don't. My example 5 is going to be different from their example 5, okay? And my example 5, I mean, really, it's 6 of one, half a dozen of another, but I don't want you to just have book stuff regurgitated. So here we go. Here's my example 5. It is going to be simplify 8t plus the product of 3 times the difference of 4t and -9. Well, we've always been taught to do what's inside parentheses first, but when you have a variable and a number, you can't do anything with them. So you have to then think a different way how you can simplify this scenario, which is going to include distributing. Okay? You're going to distribute the 3 over the parentheses. Okay? That 3 has to get multiplied by both pieces. Since you can't combine these together and multiply them by 3, you have to multiply each piece by 3 separately, which gives you to 12t minus 27. Okay? T is still out there waiting for its arrival. 8t plus 12t minus 27. So 20t minus 27 is all you need for me. 20t minus 27. You do not have to write, and you won't see it written that way anywhere in your book, okay? You will not see it written anywhere like that in your book. You can use this thought process to make sure you're correct when you're working with numbers, but don't think you have to write it this way. I would prefer you simply state it to me in that simple form, okay? It's simpler because there's only one operator. Instead, over here, there's an operator and a symbol, and that's just too much for me to think about. Last example. This is example 6, and to me, it's the same can of worms as what I just shared with you, but I'm going to go ahead and do that. The only difference is we're going to have some, well, anyways, I'm going to show it to you. Okay, this is my example 6. So it's simplify 4 times 2x squared minus x minus 1. And just notice the previous one, actually I think mine are flip-flopped. I think this should be example 5, whatever. In the previous one, when we got done with our t's, it was that 12t and 8t, we had to combine those because they were like terms. Do not forget to do that. Okay, combine like terms. Combine all your variables that are to the first power. Combine all your variables that are squared. Okay, don't ever leave me with, you know, a bunch of stuff. Simplify it wherever you can. The 2x squared minus x minus 1 cannot be simplified any further than that. So we have to simply distribute the 4 over the parentheses, which is 8x squared, right? 4 times 2x squared. 4 times negative 1x is negative 4x. And 4 times a negative 1 is a negative 4. There is nothing more that can be done because your x's are different degrees. This is a degree of 2, that is a degree of 1. So these two items are not the same item and so cannot be combined. Okay? That then there would be your final answer to that type of a problem. Okay? I hope you guys feel okay about this lesson. Is there anything that you would like me to go back over perhaps? All right.